So this year, India's monsoon didn't just arrive, it kicked the door down. It was super early, incredibly intense, and it honestly caught a lot of people by surprise. We all saw those images, right? Flooded streets in major cities, way before anyone expected. So the question is, what was actually going on?
I mean, just look at this. Weather stations in places like Mumbai were clocking in the wettest May in a century. A full 100 years. This wasn't just a little bit of early rain. No, this was a historic, record-smashing weather event.
So why? What caused all this? Well, it's a genuine meteorological mystery, and that's exactly what we're going to do in this explainer. We're going to follow the clues, we're going to look at the evidence, and we're going to solve this thing together.
Okay, let's start our investigation with the hard numbers. Just how early are we really talking about here? The monsoon officially made landfall on May 24th. That is a full 7 days ahead of its usual expected June 1st schedule. But to really get why that's such a huge deal, we first have to ask a more basic question. What does monsoon onset actually mean?
You'd think, right, that the first rain of the season is the official monsoon. But it's not quite that simple. You see, the onset is a very specific, scientifically declared event. It's about a whole lot more than just the first few drops of rain.
At its most basic level, a monsoon is just a huge, seasonal reversal of wind. In the summer, as you see here, the winds blow from the southwest, picking up tons of moisture from the ocean and dumping it over the Indian subcontinent. Then, in the winter, they completely flip.
So how do meteorologists know for sure, like officially know, when the monsoon has arrived? Well, they don't guess. They have this really strict 3-part scientific checklist that they have to follow. And here they are, the 3 official tests. To declare the onset of the monsoon, the conditions have to pass a rainfall test, a wind test, and a radiation test. Let's break down what each of those means.
First up, the rain. And this isn't about a quick shower. The rain has to be widespread and it has to be sustained. Specifically, at least 60% of these 14 key weather stations have to get 2.5 millimeters or more of rain for 2 days straight.
Second, the wind. And listen, we're not talking about a little breeze you'd feel on the ground. Meteorologists are looking for a deep, powerful flow of westerly winds that goes all the way from the surface up to 5 kilometers in the sky. That confirms the whole atmospheric system has made its big seasonal shift.
And finally, there's the radiation test, and this one is pretty clever. Think of it like this. On a clear day, the Earth's heat just radiates out into space. But, as this shows, thick monsoon clouds act like a giant blanket trapping that heat. So when satellites see less heat escaping, they know for sure that a massive, sustained cloud cover is in place.
Okay, so now we know how the onset is officially declared. Let's get back to our mystery. What forces were so powerful that they made all 3 of those tests pass a full week ahead of schedule? It's time to meet our 5 main suspects. Suspect number 1, intense heat. Central India was just baking. It was unusually hot. This created a massive low-pressure zone that basically acted like a giant vacuum cleaner, creating a powerful suction that started yanking moist air in from the ocean. Next up, something called the Mascarene High. This is this huge high-pressure system way out in the southern Indian Ocean, and it acts as the monsoon's engine, pushing the winds toward India. Well, this year, that engine was supercharged. It was shoving those moisture-filled winds north with way more force than usual. Then we have our third suspect, the Somali jet. Think of it as a temporary low-level jet stream that's basically an accelerator. This year, it was extra active, literally grabbing those moist surface winds and dragging them toward India at incredibly high speeds. Our fourth suspect is the Madden-Julian Oscillation, or MJO. Now, the easiest way to picture this is as a massive, planet-circling pulse of rain and clouds. And just by sheer chance, its most active heavy rainfall phase was parked right over the Indian Ocean, adding another huge layer of instability to the whole mix. And our final suspect's influence comes all the way from the Pacific Ocean. The world was just shifting out of an El Niño phase, which usually kind of puts the brakes on India's monsoon. But as the Pacific went neutral, it was like taking your foot off the brake and slamming on the gas at the exact same time, because it also had this knock-on effect of strengthening that Mascarene High even more. So, we've reviewed all the evidence, we've lined up our suspects. I think it's time to close the case and deliver the verdict. And the verdict is, when you look at this list,
You see the crucial point. It wasn't just one of these factors. It was all of them working together. It was a conspiracy. You had a powerful pull from the land, an extra strong push from the ocean, an accelerator in the atmosphere, and just perfect timing from two massive global weather patterns.
It was, in short, a perfect storm. The incredibly rare synchronization of these 5 different meteorological forces created this combined effect that was just overwhelming. It pulled the monsoon onto the subcontinent with a speed and a force that we haven't seen in generations.
This whole event was described as a once-in-a-century kind of thing. But with factors like intense land heating becoming more and more common in a warming world, it leaves us with one last big question. Are events like these about to become the new normal?